to the IROBEX BattleBot competition awareness session on how to make a battle robot. My name is Liguru Navaratna and I'll be your host for today. We have a very exciting session lined up for you, especially if you're passionate about robotics and looking forward to building your own BattleBot. This session is all about learning the intricacies of making a battle robot, and I'm sure you're as thrilled as I am to get started. Without further ado, let's move on to introducing our esteemed speakers for today. We have with us Mr. Chamira Vijayatunga, Associate Tech Lead at Zone 24/7 Private Limited, and Mr. Sandaruvan Madhushankar, the Electronics Engineer at 24/7 Private Limited. They bring a wealth of knowledge and experience in the field of robotics and technology, and we are truly fortunate to have them here to share their insights. So, before we get started, I'm pretty sure most of the participants will have their own questions regarding today's sessions. Don't worry, the meeting chat is available, so you can drop in your questions whenever you have a question during the session. And at the same time, we have a Q&A session towards the end. Now, without further ado, let's kick things off. I'll hand it over to our guest speaker to take us through this exciting session on building battlebots, Mr. Chamir.
Right. Thank you, Lavero, and good evening to everyone. So, as let me share my screen first. Can someone confirm whether my screen is visible and I'm audible enough?
Yes, Chamira, yeah, audible and visible.
Yeah. Thank you very much. So, welcome to the session how to make a battle bot. So both myself and Sandruvan, my friend, will be sharing some knowledge that we have collected over 5 years with all of you. So let's start today's session. Like as Laviru mentioned, the chat box is open. So if you have any questions, without being delayed, please put those questions in the chat box. At the end of the session, we will answer all of your questions. All right. So let me introduce myself a bit. So I'm Chamira Vijayatunga, currently working as an associate tech lead at Embedded Systems at Zone 24/7 Private Limited. So I completed my BSc in Electronics and Telecommunication Engineering, University of North a couple of years ago. So during my university time and industrial time, I have been participated in many battlebot competitions and secured some wins as well. So let me share some of the insights and the knowledge that we have gathered over the last several years. Let's see what are we going to cover today. So first we will peek into who is a battlebot. So I know most of you might have heard this word battlebot, and most of you have built a battlebot in this year or the previous years. So we will dig into the history of battlebots and battlebot competitions. We will go through the general rules when it comes to battlebot competitions and the rules that are applicable in Sri Lankan context especially. And we will walk you through the component selections, like what are the major components and how do you choose, what are the parameters that you have to consider when selecting a component. Also, after selecting the components, there are several considerations when it comes to developing the hardware side of the battlebot. So we will go through all of them as well. And later, my friend Sadhurvan will guide you through some driving strategies and defensive mechanisms and the MCAT-based designing, like how you can improve your battlebot using the MCAT-based designing solutions, and also how to be prepared for repairs and maintenance during the competition day. So let's we will do this session in English. Both of us will be repeating some of the important points in Single as well. So feel free to put all the questions in the most comfortable language to you. If you're comfortable in English, please put in English. Otherwise, you can put all the questions in Single as well. Uh, so message box is open. Put your comments while we are doing this session. Right. Let's see who is a battlebot. So a battlebot is, so this is the basic definition of a battlebot. Someone else will have another definition. This is the definition that most part of the world is agreeing with. So a battlebot is a fast-moving, remote-controlled robot designed for combat purposes, typically equipped with a weapon, one or two weapons, with a defensive mechanism, and used in competitive battles against other robots. So how do we differ a battlebot from an autonomous robot? So a battlebot is a remotely operated robot. So you can have a remote control on your hand and control the battlebot using that remote. Uh, if you think about an autonomous robot competition, your robot is autonomous. You cannot control the robot via a remote. And this robot is kind of fast moving and combat enabled robot. So this robot has to fight with another robot and defeat that particular robot to win a match. So in autonomous robot, you just have to complete all the tasks within a given time, uh, as accurate as possible, right? So, but in a battle bot, what you have to do is you have to fight against another robot and kick that other robot out of the arena or damage the other robot and secure your position. That's what a battle bot is. So these battle bots are usually combating with another robot usually. So sometimes like uh, in some games you have to fight with two or three robots at a time. So but in Sri Lankan contest we only fight with just one robot at a game. So there will be several games during a competition, so you will be have to fight with several robots at different games. Right. So before starting about the general rules, let's see how this BattleBot started. So in 1990, the Denmark Scientific Society organized the first BattleBot competition. You can see an image of it. So this was the first BattleBot competition happened in the world. So these robots are controlled using a wired remote, not a wireless remote, a wired remote. So this was the first BattleBot competition happened in the world, which was took place in 1990. And coming to 2000, the American competitive television series called BattleBots started on Comedy Central. So now we have, I think, 10 or 12 seasons of it. So you can go to YouTube and watch all the seasons of the BattleBots. So that's where the BattleBots got changed its path. So from 2000 to 2024, we have seen a lot of changes and a lot of improvements in the BattleBots throughout these 24 years. And in the last year, in 2023, uh, we had the National Hawk Robot League becomes the biggest robot combat event in the world, like with the $2 million prize pool. Like that was the biggest prize pool ever in BattleBot competition, and we haven't seen this event happening in this year. I guess it will be happening in 2025 or 2026. So the prize pool will be getting much bigger than what we had in 2023. Uh, so let's say how BattleBot competitions what are the battle boat competitions held in Sri Lanka. So it all started in 2016 with the University of Uvavella's battlebot competitions. So Uvavella's University brought this battlebot culture to the Sri Lankan context in 2016. After that, we had Chromium Collision, which was organized by, I think, Dialogue, and Chris Explosion by University of Caroni, and several Uvavella's robotic battles as well. And CLT also organized one battlebot competition. And early this year, we had another death race battlebot competition happened in Uvavella's, and 2 months ago we had electro combat organized by USGP technology faculty battlebot competition in June or July, if I'm not mistaken. And at the end of this month, I guess 25th or 26th, we will have the NIBM IROBEX battlebot competition. So this is a good year for the this is the, I would say, the best year for the battlebot competitors, because in this year we are going to see 3 battlebot competitions happening in Sri Lanka. That's a good trend actually. So thank you very much for NIBM for organizing the 3rd event in a row in this year. So so if you have seen or if you have watched the YouTube live of the USGP BattleBot competition, you might see most of those robots in the NIBM iRobots as well. So once you build a BattleBot, you can use that BattleBot for several upcoming BattleBot competitions as well. So if you have participated in USGP, you will be also participating in the NIBM iRobots. That's a culture. And some will be making their first BattleBot for the NIBM iRobots. So the one who have already made the BattleBot can learn how to improve your BattleBot from this session, and so, the people who are going to build your BattleBot for the first time, I guess you can learn a lot from this session, right? Right. So let's go through the general rules when it's come to BattleBot competition. So these limits or these constraints are there to make the game fair for everybody. So everyone is under a weight limit, a dimension limit, and a voltage limit. So everyone will be who are participating in a game are fair. So that's the main point of having these constraints and rules. So here I'm going to walk you through the general rules of a battlebot competition in Sri Lankan context. So these are not always going to be your roles in the upcoming battlebot competitions. So what you have to do is first go through the rule book or the design guidelines provided by the particular competition organizer. So if you are going to participate in IROBEX 2024, there will be a guideline or the rule document which had been already shared with you. So build your robot according to those rules. I will go through these rules. These are the general rules in Sri Lankan context. So the max weight will be around 10 to 15 kilograms of your robot, and the max dimension, the width and the height, width and the length will be 45 by 45 or 40 by 40 centimeters, and the height there will be a height limit like 40 or 50, and there will be max voltage. Most of the time, that's 48 volts. So, and the bot has to be equipped with at least 2 master kill switches, one switch for your driving mechanisms, and the other one for the weaponry system. And the arena, the fighting area will be 10 feet by 10 feet arena, which will be made out of steel, aluminum. There will be 2 or 4 pits at the diagonal corners of that pit. So you have to push the other robot, your opponent, out from that pit. And in Sri Lankan context, like all kind of combustion engines, petrol, diesel, all kind of combustion engines are prohibited. Also in this competition, I guess vapors, gases, liquids, flames, fires, projectiles are not allowed. Also, you cannot use EMP or signal jammers, and lasers you cannot use. So the points will be given depending on how does your robot damage the other robot, and how do you control your robot, and how do you show the aggressiveness of your robot. So these are the general rules. So as I mentioned earlier, you can go through the rule document of the NIBM IROBEX that I think you have now, and build your robot according to this. So my point එකයි කිව්වොත් එහෙම මේ මෙතන අපි කතා කරේ ලංකාවේ හදන ලංකාවේ තියෙන battle bot competitions වල තියෙන general rules ගැන. එතකොට මේ rules වෙනස් වෙනවා competition එකට. එතකොට ඔයාලා මේ IROBEX competition එකට participate කරන්න නම් ඉන්නේ competition එකට robot හදන්න කලින් ඒගොල්ලෝ share කරලා ඇති design guideline නැත්නම් competition rule book කියලා පොඩි PDF එකක්. ඒකේ තියෙනවා robot තියෙන්න පුළුවන් උපරිම බර, size එක, voltage එක, range එක මොකද්ද, pitch කීයක් තියෙනවද range එකේ, බලවල් කීයක් තියෙනවද range එකේ, මොනවද පාවිච්චි කරන්න පුළුවන් weapons, මොනවද පාවිච්චි කරන්න බැරි weapons, කොහොමද ලකුණු දෙන්නේ, කොහොමද දිනන කෙනාව decide කරන්න කියන දේවල් ටික ඒගොල්ලෝ share කරලා ඇති. ඒ ටිකට ගිහිල්ලා තමයි බලන්න ඕන ඔයාලගේ මේ competition එකට ගැලපෙන්නේ මොනවද කියලා. මෙතන තියෙන්නේ general rules making හරි මොනවද කියන එක ඔයාලා guideline එක බලලා apply කරගන්න. Open clear. Moving forward, now we have to we had a look about the general rules. Now we have to select the components according to those rules, right? So let's see what a BattleBot is consist of. So BattleBot generally has a good chassis, and there will be 2 or 4 or whatever number of motors, and there will be wheels or tracks to give the mobility to the robot. And also there will be one or several power sources to give powers to the motors and for the weapon. And there will be a remote controller, and there will be motor driver to get the signal from the remote controller and drive the robot, drive the motors accordingly. And there's an electronic system which consists of like more drivers, microcontrollers, batteries, switches, so on. You have a weaponry and an armor, So there will be other safety components as well, such as switches, fuses, those kind of things. So in later slides, what we are going to do is we will go through each of these components and see what are the best practices and the design considerations that you have to take care of. Right. Chassis. The first and most important part of a BattleBot is the chassis. So chassis is the backbone of the BattleBot, right? Like there will be no BattleBot if you don't have a proper chassis. So if you take autonomous robot, the chassis is made out of most of the time the PCB itself or a perspex board, right? So but in a BattleBot, you have to think about 3 major concerns, 3 major factors when selecting a proper chassis. The first one is the material that you are going to use. So the chassis is going to provide the structural support and the housing for all the components. So the material is really important here. So you can use materials like aluminum, steel, or wood after considering the factors like its strength, weight, and the cost. Do not use plastic or 3D printed stuff or perspex, those materials for the chassis. ඔයාලගේ robot ගේ chassis එක හදනකොට අනිවාර්යයෙන්ම aluminum, steel, lead ඒ වගේ material එකක් use කරන්න, carbon fiber ඒ වගේ එකක්. 3D print කරපුවවත් plastic වත් perspex වත් කිසිම හේතුවක් නිසා use කරන්න එපා. මොකද ඔයාලට battle කරන්න වෙන්නේ අනිවාර්යෙන් එතනට ආවට පස්සේ metal chassis එකක් තියෙන robot කෙනෙක් එක්ක. ඒතකොට ඔයාලගේ robot කිසිම chance එකක් නැහැ metal robot එක්ක fight කරන්න. ඒ වගේ perspex robot කෙනෙක් හදාගෙන ආවොත් අනිවාර්යයෙන් ඔයාලගේ robot සෑහෙන ලොකු damage එකකට පත් වෙනවා. And you have to consider about the strength, weight, and the cost when you are choosing the material. Also, you have to think about the weapon that you are going to use when you are designing the selecting the material. And as for the design, you have to design the robot to be stable, movable, and it has all the protection. And also, you have to consider the combat strategy or the weapon that you are going to incorporate with the robot. Like, let's say, for an example, like if you are using fire as a weapon, fire is not allowed in most of the conditions, but uh, if you are going to use fire as a weapon in any other competition, if you're going to use fire as a weapon, you cannot use wood as your chassis, right? Your robot can catch fire by itself. So you cannot use fire if you're using a wood chassis. So considering those factors, you have to think what are the what are the what are the what is your combat strategy and what is the weapon that you're going to use. Based on that, you have to select the material and the modularity. Uh, you have to consider the modularity of the robot. What do we mean by modularity? Let's say during a robot, you have to change your wheels during a competition. After a game, you have to change your wheels. You have to change your motors, motor drivers, batteries. Most of the things you might have to change because at the game you will get everything destroyed or everything can get damaged. So because of that, you have to have provision. You have to have provision to change those motors or the motors or wheels with the minimum amount of time. Right? You have to prepare your robot for a game within 10 minutes. You have to charge your batteries. You have to change all the burnt components. You have to replace all the damaged components within 10 minutes. Organizers will never give you more than 10 minutes to do a repair. So considering that factor, like you have to modularize your chassis, right? Like if you want to replace a wheel, you can be done. It might be you might be able to do it by unscrewing like 4 or 5 screws. Like if you have to separate all the components just to replace a wheel, there is no point in developing a chassis, right? ඔගොල්ලෝ රොබෝ හදනකොට රොබෝගේ ඕනම කම්පෝනන්ට් එකක් ඉක්මනට මාරු කරන්න පුළුවන් වෙන හදනවා. මොකද ගේම් එකකින් ගේම් එකට විනාඩි 10ක් වගේ අතරතුර ඔයගලන්ට මෝටර්ස්, වීල්ස්, බැටරිස් වගේ දේවල් මාරු කරන්න වෙනවා. එතකොට ඔයාලට බැටරි එකක්, වීල් එකක්, මෝටර් ඩ්‍රයිවර් එකක් වගේ මාරු කරන්න මුළු රොබෝවම දෙකට ගලවන්න වෙනවා නම් ඒකේ ඒ ඩිසයින් එක ඇත්තට හොඳ ඩිසයින් එකක් නෙමෙයි. ඒකට ඔයාලට අඩුම එන සංඛ්‍යාවක් වෙන 4කින් 5කින් වගේ ඕනම දෙයක් මාරු කරන්න පුළුවන් විදිහට මොඩියුලරයිස් විදිහට රොබෝව හදන්න ප්‍රක්‍රියාව. Right. Let's see some chassis designs. So these are several chassis designs that you can see mainly in Sri Lankan context. So this is the skeleton of a chassis. So as you can see, this chassis is made out of aluminum profile. So this is a really good chassis. As you can see, like there are several compartments where you can place the motors, batteries, and the electronics. Right. So these are not like if you need to replace a battery or a motor, you don't have to separate the chassis, right? You just have to uncover the top cover and replace whatever the component that you want to replace. So these are the basic chassis designs that you can see in Sri Lankan context. So as I mentioned earlier, like if you are using this kind of a weapon, your chassis should be able to withstand this kind of weight in front of the robot, right? So otherwise, when you place this horizontal spinner at the top of the robot, these two wheels will not touch the ground if you haven't properly designed the chassis. So think about those factors as well. And this is another good chassis. So as you can see, the wheels are exposed from the bottom as well as from the top. So if your robot got flipped, you can drive upside down. So these are several chassis designs you can see mainly we saw several of these in the USJP and the UW competition happened in this year. We hope to see several good designs in this competition as well. Right. So now you have selected the materials and the design of your chassis based on design that you're going to make. So let's see what are the manufacturing facilities, manufacturing methods that you can use to manufacture the chassis that you want to make. First one is milling. Uh, Using milling machines to precisely cut, mill or drill and shape the metal blocks, you can create your own chassis. What milling does is like it will take an entire metal block and cut and drill through a metal block and create a shape as you can see in this image. So this is first this is a entire metal block of aluminum, and using the milling machine you can cut the unwanted parts out and create some kind of this kind of a chassis. Also, you can create this kind of a chassis uh, by laser cutting. You can laser cut each of these parts separately, then fix them together. That is another way of making the chassis. Also, you can use welding and fabrication. So, similar to what I mentioned earlier, you can separately make components individually and later fix them using welding and fabrication methods. You can use also sheet metal fabrication. In sheet metal fabrication, you can cut, bend or form any sheet metal into the desired shape using tools like shears, brakes, and presses. Laser cutting we discussed. And composite materials. You can utilize materials such as carbon fiber, fiberglass, or Kevlar to create lightweight and durable chassis structures. So if you can use carbon fiber, very expensive, but if you can use it, you can afford. If you can afford it, it's very durable and lightweight than metal. So you have more weight to put to other components as well. And there is another method called 3D printing. I think most of you have heard this term, and most of you have used this technology. So 3D printing is good to create some sockets, some brackets inside the chassis, not the chassis itself. You cannot create the entire chassis using 3D print. What you can do is after making the chassis using a metal or something like that, you can manufacture customized brackets to hold the battery, hold the motor drive uh, onto the chassis. 3D printing වලින් full chassis එකම ගහන්න බෑ. එහෙම ගහගෙන આવත් මනිවාරෙන් මේ දෙකට කරන රොබෝ කම්පිටිෂන් එකක් නැද්ද? 3D print වලින් කරන්න පුළුවන් ඔයාලා metal වලින් හදන රොබෝට parts fit කරන්න brackets වගේ හදාගන්න. දැන් battery එහෙම තිබ්බට පස්සේ battery හෙලවෙන්නේ නැති වෙන්න mount එකක් bracket එකක් හදා ගන්නවා නම් ඒක 3D print වලින් කරන්න පුළුවන්. electronics components mount කරන්න bracket එකක් ඕන නම් 3D print වලින් කරන්න පුළුවන්. හැබැයි motors mount කරන්න බෑ 3D print කරපු ඒ වගේ. මේ වගේම full chassis එකම 3D print කරන්න බෑ. So those are the basic ways that you can manufacture the chassis. Now you have a chassis. Next, what you have to select is the motors. So there are several types of actuators that you can use in the battle board. Here we are looking at the actuators or the motors that you can use to give your robot the mobility. So using these one or two of these motors, you can make your robot movable, right? So there are several types of actuators: DC brushed, brushless DC, stepper or servo, and pneumatic and hydraulic actuators. So out of these four, the most suitable types of motors are DC brushed and brushless DC motors. Stepper and servo motors are designed for precise control and uh, to generate precise control rather than generating a high torque. And also, because of that, we cannot use steppers or servos directly as the motors of the robot. So when we considering a battle bot, you have to have high torque motors and high speed motors. So steppers and servos are designed for high precision, not for high torque or high speed. So because of that, you cannot. It is not a good practice to use steppers or servos. And pneumatic and hydraulic components, hydraulic actuators, those can give high torque and high speed. But the thing is, you have to compete with the other opponent for 3 or 5 minutes, right? Uh, you have to be in the game for 5 minutes. That's it. So you cannot store enough compressed air or compressed liquid inside your robot for 3 or 5 minutes. Right? That's the case. So since since this is a uh, mobile robot, you cannot use pneumatic or hydraulic because uh, the energy storage part is difficult for pneumatic and hydraulic. But when it comes to DC brushed or brushless DC, both of these motors are very simple and efficient. So if you go with DC brush, it is cost effective and have very high starting torques in these models. Brushless DC offer high power to weight ratio and smooth operation. So when it comes to BattleBot, you have to uh, your robot has to stop, go more. Your robot has to undergo a lot of stop and go motions. Like you have to wait to understand the other robot's strategy and move fast and brake. You have to do everything. So for that, you have to have a higher starting torque as well as the speed. Because of that, DC brushed and brushless DC motors are suitable for your robot. Right. When it comes to DC motors, there are two subcategories. The first one is motors without gearbox and the motors with gearbox. Out of these two, what we would suggest is to go with the gearbox motor. Right? Uh, DC motor without a gearbox is not suitable for a battle boat. Means you are directly coupling your motor uh, to the wheel. It is not suitable. That's because of the torque output will be limited, and these motors will get overheated under high load and high speed. So if you go with a gearbox one, so you have a DC motor, you connect a gearbox in front of, and then attach the wheel to it. So that is the best combination for a battle boat if you are using DC motors. So gear motors provide higher torque output, and it will generate precise controlling because the motor speed is higher than the wheel speed. Wheel is rotating less because of the gear ratio. So the control will be very precise. Right. The other type of motor was VLDC motors. Uh, in VLDC motors also, there are two categories: high kV with gearbox and low kV hub motors. Both of these types of motors are suitable for a battle bot. So if you're using high kV with gearbox, it gives high rotational speeds, allowing for swift and agile movements, and the gearbox enables the motor to deliver varying levels of torque because of the gear ratio. So if you're using hub motors, it is very simple to attach it to your robot. You don't have to think much about the mounting kind of stuff. The motor comes with the wheel, so you don't have to do much when it comes to assembly. So these motors are a bit expensive than DC motors. So if you are high on budget, you can go for this kind of motors as well. Right. Now we have a chassis. Now we have motors. We have to select wheels or tracks that you are going to use, right? There is very simple rule, one simple rule when it comes to selecting the wheels or the tracks. If the terrain is hard, if the flow is hard, use hard tires for the durability. If the terrain is soft, the flow is soft, use soft tires for tracks for the traction purposes, right? Let me give you an example. Uh, in the battlebot competition we had early this year in 2024 January in ULS University. There was a death race. So Robert had to go through a carpet road and while competing with the other robots. So the terrain was really tough, really hard. For those kind of terrains, you have to use hard tires. So if you use very soft rubber tires, your tires not will not be there until you end your race. Your tires will worn off, right? So for that kind of terrains, you have to have very hard, rigid tires for the durability purpose. So in a typical battlebot competitions, what we had 2 months ago in USJP, and that what we are going to have in NIBM at the end of this month, the terrain will be very soft. Terrain will be an aluminum sheet, right? The terrain is soft. Then you have to have, then you have to use soft tires, right, for traction. Otherwise, the opponent robot will easily push you out of the pit. ඔයාලගේ රොබෝ කම්පීට් කරන ටෙරෙන් එක ගැන සර්ෆස් එක ඒක ටිකක් හાર્ඩ් සර්ෆස් එකක් නම් ඔයාලට අනිවාර්යෙන් හાર્ඩ් ටයර්ස් යූස් කරන්න වෙනවා. ඔයාලගේ ටෙරෙන් එක සොෆ්ට් වැඩි තද නැති ටෙරෙන් එකක් නම් සොෆ්ට් ටයර්ස් අනිවාර්යෙන් යූස් කරන්න ඕන. හොඳ ෆ්‍රික්ෂන් එකක් ගන්න. හොඳට බදලා අල්ලගන්න. දැන් NIBM එකේ තියෙන කම්පිටිෂන් එකේ තියෙන ඇලුමිනියම් ෂීට් එකක් ඒක සොෆ්ට් ෂීට් එකක් තමයි ඒකදී හම්බෙන්නේ. ඒක පොඩි පොඩි වයිරම් වගේ තියෙයි. හැබැයි සාපේක්ෂව මැටීරියල් එක සොෆ්ට්. එතකොට ඔයාලගේ රොබෝට සොෆ්ට් ටයර්ස් තමයි යූස් කරන්න ඕන. හොඳ ෆ්‍රික්ෂන් එකකින් ටෙරෙන් එක බදලා අල්ලගන්න. ඒක හොඳට ගන්න ඕන ඩිසිෂන් එක. Right. So let's go through the factors that you have to consider when selecting wheels or tracks. First one is traction. So the tire, track or wheel should provide higher traction to the arena surface, right? For you to move your robot efficiently and get a pushing force. And the diameter of the robot is very important because if the diameter is high, your robotic speed is high. Otherwise, your robot will not be able to move faster. And the durability, as I mentioned earlier, you cannot use regarding the rim or the wheel of the robot, you have to have metal or some rigid wheels. අර කහපාට මෝටරෙත් එක්කන කහපාට වීල් එකේම මෙටල් බොට් කෙනෙක්ට සූටබල් වෙන්නේ නැහැ. මොකද ඒක ඒ ටෙරෙන් එකට ගැලපෙන්නේ නැති නිසා මෙටල් බොට් කෙනෙක් කියන්නේ හයි ඉම්පැක්ට්ස් වලට ගොඩක් ගැටුම් වලට මුහුණ දෙන රොබෝ කෙනෙක්. එතකොට ඒ වගේ ගැටුමකදී ඔයාලගේ කහපාට මෝටරෙත් එක්කන කහපාට වීල් එකේම ප්ලාස්ටික් වීල්ස් එකක් කඩලා යන්න පුළුවන්. Because of that, you have to have more wheels with more strength. Size and the clearance. You have to consider the size of the robot when you are selecting the wheels. Also the weight. If you are going for a very bulky, very heavy weighted wheels, you will not be able to move your robot quickly, right? There will be starting inertia, so you will be not getting enough starting torque. And make sure your wheels are compatible with the drive system. So if you are using two motors, you think about what are the types of motors and how do you design your drivetrain. And you also have to have protection for these wheels as well. So what you can do is you can have a separate a guard for your wheels to avoid impacts, direct impacts to your wheels. If the other robot directly hits your wheel, and if your robot wheel is broken, you don't have any chance to move your robot anymore. Right. Now we have chassis, motors, and wheels. Let's see how we can connect these wheels to the motor. So there are three types: direct drive, belt drive, and chain drive. So as you can see in this image, direct drive is directly coupling the motor to the wheel. Belt drive is you are using two pulleys and a belt to transfer the energy from the motor to the wheel. And in chain drive, you use a chain and two sprockets to transfer the energy from the motor to the wheel. So there are advantages and disadvantages in each of these mechanisms. Let's see what are those. If you're using direct drive, it is very simple. You just have to directly couple the motor to the motor to the wheel. That is compact and very lightweight, low maintenance. Like you don't have to maintain those structures a lot. But the uh, disadvantages are uh, if your robot, if your wheel gets an impact, that impact will be directly transferred to you to the motor of your robot. So if the motor is also going to break, that's not a good design. And if you are thinking about the belt drive, that is also very good mechanism. You can have a flexibility in gear ratio, and the power transmission will be smooth, and vibration and noise will be reduced. So because the wheel and the motor is not directly coupled, shock absorption is really good in this design. But the thing is, if you are using either belt or chain drive, you have to maintain those a lot. Like you have to retension the chain or the belt, and you have to put oil, and and those mechanisms are bulky, not lightweighted. So it adds another weight to the robot. Those are the disadvantages. In chain drive, the top transmission is high, and the durability and reliability is really high. So think about the downsides and upsides of each of these mechanisms, and select the most useful uh, driving mechanism or the coupling mechanism based on the design that you're going to make. Right. Now we have to select a power source for your robot. So these are the three major battery types available in Sri Lankan market: lithium polymer, what we call as LiPo, lithium ion, and lead acid. Lead acid does include the car batteries; those have sulfuric acid inside this, and these are really bulky batteries. Because of that, this is not suitable, because if the other robot punctures through this battery, your robot will be dead, and there will be a lot of disasters happening to the arena as well because of sulfuric acid leaking onto the arena. And out of lithium polymer and lithium ion, lithium polymer is the most suitable battery because the current is high than lithium ion. So this is the most suitable. If you cannot afford or if you cannot find lithium polymer, go for an lithium ion battery. Right. So what are the things that you have to consider, or that you have to think when when it comes to selecting the battery? The first one is the capacity. Capacity is the amount of energy that you can store inside the battery and measured in milliampere hours. Also, the voltage. Voltage is the potential difference between the positive and negative terminal of the battery. Cell count means how many cells are connected in series or parallel in your battery. Like a single cell is a single lithium ion or lithium polymer cell is rated at 3.7 volts, the typical voltage, nominal voltage. So if we stack two of those in series, the output voltage will be 7.4. If you stack three in 3 series configuration, output voltage will be 11.1. Uh, and the discharge rate and the charge rate. Discharge rate specifies what is the maximum current that you can draw out from the battery at a given moment. Similarly, charge rate specifies what is the maximum charging current that you can input to the battery during a charging cycle, which determines how long will it take to charge the battery. Right. This is a typical lithium polymer battery example. So I will walk you through each of these parameters. Here, you can see the capacity is mentioned as 2200 milliampere, right? So what does it say? So 2200 milliampere hour can be divided into these two formats, right? These are the basic two formats that you can divide into. That is uh, 2200 into 1 and 1100 into 2. So what does this say? This says if you are drawing 2200 milliamperes out of this battery continuously, it can give this much of current for an hour. ඔගොල්ලෝ මේ මිලියම්පියර් 2200ක් අදිනවා නම් මේ බැටරියෙන් කන්ටිනියස්ලි මේ බැටරියට පැයක් කාලයක් ඒ එනර්ජි එක ඒ තරම් කරන්ට් එකක් ලබා දෙන්න පුළුවන්. Similarly, if you are drawing only 1100 milliampere, 1100 milliampere, this battery can last for 2 hours. ඔගොල්ලෝ අදින්න මිලියම්පියර් 1100 නම් මේකට පුළුවන් පැය දෙකක් ඒ කරන්ට් එක ලබා දෙන්න. ඒක තමයි capacity එක කියන්නේ. Right. So the other important parameter is the cell count. It says 3s. 3s means there are 3 cells connected in series inside this battery pack. So then we can calculate the voltages, right? So as I mentioned earlier, typical lithium polymer lithium ion nominal voltage is 3.7. So if you connect three batteries in series, the total voltage of the battery pack will be 11.1. So you can charge each individual cell into 4.2 volts. So 4.2 into 3 means 12.6. This is the fully charged voltage of this battery. So if you are taking a 2s battery, you have to multiply this by 2. And a typical, usually you do not discharge this battery below 3.3 volts. It will damage the battery. Like an individual cell below 3.3 volts, it will damage the battery. So when you are discharging the battery, if a single cell comes to 3.3 into 3 means 9.9. So the lowest voltage that you can get safely out of this battery pack will be 9.9 volts. And this information, the nominal voltage, is mentioned here in the battery pack as well. Here you can see the discharge rate. Right? It says 40C discharge. What does it mean? So to get a measurable or get a sensible number, you have to multiply that C number with the capacity. Here what I have done is I have multiplied this 2200 milliampere by 40C. It gives 88,000 milliampere, namely equals to 88 ampere, right? 2200 milliampere hour into 40 is 88 ampere. This 88 ampere is the maximum continuous current that you can draw out from this battery. මේක මේ තියෙන capacity එක 2200 මේ 40 වැඩි කරාම එන 88000 milliampere කියන්නේ milliampere ampere 88යි කියන එක. ampere 88ක් තමයි මේ battery එක දිගට අදින්න පුළුවන් වැඩිම current එක. ඊට වඩා current එකක් ඕගොල්ලෝ draw කරොත් මේ battery damage වෙනවා. That's what this discharging C means. Similarly, a typical lithium polymer ion charging rate is 1C. So if you multiply that by 2200 milliampere hour, you get 2.2 ampere. So this is the charging current that you have to set in the balance charger to charge your. This is the maximum current that you should set on the balance charger. Right. So now you know what are the things that you have to consider when selecting a battery. Let's go through how to protect your battery. Let's go through details of the points that you can take care of to protect the battery. Do not overcharge or over discharge the battery. Now you know what are the discharging limits and the charging limits. So do not overcharge or over discharge. Use a LiPo-compatible charger or a balanced charger. I have shown you IROBEX B6 charger. This is the most compatible and the most available battery charger in the market in Sri Lanka. So you can use this kind of a charger to charge your battery and use with the recommended discharge and charging rates. You have to place your robot, place the battery inside the robot very securely. There shouldn't be any room for the other robot to puncture or damage your battery. And choose correct power wires and connectors which can draw the current that you require. And when you are storing or when you are transporting the battery, make sure to store this battery in a cool, dry place away from flames. And after each match, you have to inspect the battery whether there are any punctures or do you see any smoke coming out of the battery. You have to check after each match, and do not puncture or do not throw the battery away, and take care of this battery, like worship this battery, and the battery will do the same for you. Right. Now we have identified several components like motors, wheels, drive mechanism, chassis, batteries. Now we have to select a remote control. Here I have shown you two different remote controls that you can purchase off the shelf in Sri Lanka or in any online marketing platform. So this is the fly sky, like what we call this as a drone remote, and these are RC car remote, right? So both of these remotes are compatible for this kind of a battery, right? And make sure to have a backup battery for this. Like these are operated in battery power, so you can have a better backup battery before starting off each match. And you have to program the fail-safe mechanism of these remotes as well. So, like if the robot doesn't receive any signal, there should be a behavior that robot should follow. So you can program those behaviors in this remote. So you can do it as well. So if these remotes are not affordable for you, these are too expensive for you, what you can do is you can make your own remote, something like this, using two Arduinos and some communication mechanisms. So this is also a good way to manufacture a robot. So before coming to the game, make sure there is enough range. uh, you test with enough range. So let's say in this game, I think the arena is 10 feet by 10 feet. So make sure you test your robot to whether it can move within 50 feet area. Make sure the range is go more than 10 feet, like around 50 feet as well, like because there is a metal mesh around around that area, so that metal mesh acts as a barrier for your remote signals. So make sure these remotes can operable in 50-meter range as well. Also, your robot is made out of metal now, so the receiver is placed inside. There are a lot of barriers for the signal to pass through to the receiver. And the most important part is, do not use smartphones to control your battlebot. Do not use Bluetooth, Wi-Fi, or smartphones to control your battlebot. That's not going to work. Okay? ඔයාලගේ battlebot control කරන්න කිසිම වෙලාවක Bluetooth හරි Wi-Fi වලින් හරි connect වෙන mobile phone application එකක් smartphone එකෙන් control කරන්නත් හිතාගෙන ඉන්න එපා. ඒක ඔයාලගේ ගෙදරදී කාමරේදී වැඩ කරාට battlebot arena එකේදී වැඩ කරන්නේ නැහැ. මොකද arena එක වටේට යකඩ මෙෂ් එකක් ගහලා තියෙන දැලක් ගහලා තියෙන්නේ. ඒ දැල හරහා සිග්නල් වලට යන්න අමාරු කෙනෙක් සිග්නල් ලොකු බැරියර් එකක් ඒ දැල. ඒක නිසා ඔයගොල්ලෝ දැලෙන් එළිය ඉන්නේ රොබෝ ඉන්න දැලෙන් ඇතුලේ. එතකොට හරි අමාරුයි මේ දැලෙන් සිග්නල් පෙනිට්‍රේට් කරන්න. ඒ වගේම රොබෝගේ ඇතුලේ තමයි මේ රිසීවර් එක තියෙන්නේ. ඒතර මෙටල් කවර් එකක් ඇතුලේ තියෙන රිසීවර් එක. එතකොට කොහොමත් Bluetooth Wi-Fi නම් හරියන්නේම නැහැ. ස්මාර්ට්ෆෝන් වල නම් කන්ට්‍රෝල් කරන්න බැරි වෙනවා එතනට ආවට පස්සේ. ඔයාලට මේ වගේ ගන්න අමාරුයි නම් ඔයාලට මේ වගේ DIY robot DIY remote එක ඔයාලටම හදාගන්න පුළුවන්. Right. Now you have the remote control and the motors. Now you have to think about a way to convert this digital signal into the motor motor controlling signals. Right? There are two ways: using a microcontroller or using an ESC. Right? So if you are using a microcontroller, what you have to do is this is the remote receiver. You have to connect this receiver to your microcontroller, then use this microcontroller to control the motors the way you want. Right? That's the first mechanism. So you have to write the code, write the firmware for this microcontroller, and to get the signal from the receiver and to drive the motors accordingly. Similarly, the other option is using an ESC or RC motor driver. Here you don't have to write any firmware or write any code for this. What you have to do is you can directly connect this this ESC to this PPM receiver and connect motors and power to this ESC. So the motor will be driven according to the remote signal. You don't have to connect the microcontroller. You don't have to write any firmware. So this is the most easiest way to drive your motors based on the remote signal. So if you are using a microcontroller, you can write your own firmware. You can customize it. You can add some speed profiles or some autonomous functions if you want in this microcontroller. So if you are using this you cannot use any customized functions, but it provides some advanced speed controlling mechanisms inside the ESC itself. Right. Going through the first part using a microcontroller, as I mentioned earlier, this is the receiver. You have to connect that to the microcontroller. What are the microcontroller that you are going to use? I'm shown an Arduino Uno. So if you're using an Arduino, you can use an Arduino firmware and connect the driving signals to the motor and connect the motors to your motor driver. So based on the signals that you receive from this receiver, you have to write the firmware to drive the motors accordingly. Right? This is the first mechanism that you can use. There is a link. I will make sure to share this presentation with you, so you can go check this link and see how to write the firmware and how to control the motors using a microcontroller. The second option is, without using a microcontroller, use an ESC or RC motor driver. Right? Here, as you can see in this picture, you don't have to connect a microcontroller. You just have to connect receiver directly to the ESC and the battery, and the motor will be driven based on the signals that are sent into this receiver from your remote. This is the brushless motor ESC. Here you can see a brushed ESC, which you can use to control brushed DC motors. Similarly, there are some RC motor drivers as well, which can drive two or several motors in differential mode to drive your robot left, right, or turn, pivot in the center. So these are also ESC types of motor drivers where you don't have to write a firmware for this. I have attached two links for this as well, for an ESC and for a RC motor driver. Right. Based on the motor that you're going to select, you have to select a motor as well, right? So if you're going to use a brushed DC motor, you can use one of these motor drivers. These are most commonly available motor drivers. So if you're using one of these, you have to have a microcontroller to convert the PPM signal into this motor driving signals. If you're using hub motors or BLDCs, you can use RC motor drivers or ESCs. So there you don't have to use a microcontroller directly. You just have to connect the receiver to the ESC itself. Let's go through some parameters that you have to consider when selecting a motor driver. First one is the voltage. Make sure uh, your motor can provide enough voltage for your motors to work. Let's say your motors are recommended to operate in 12 volts. Your motor drivers should be able to operate in 12 volts or higher voltages, right? Similarly, the current, if the current of if your motor draws more than motor draws 10 ampere at its peak, when at its peak, your motor driver should be capable of providing more than 10 amperes. Those are the basic factors when you have to consider. You have to consider when you are purchasing a motor driver or selecting a motor driver, and you have to think about the controlling interface. Some of the motor drivers provide PWM interface to control the speed. Some of them provide analog or the communication protocols to control the motors. And the protection features. Some of motor drivers protect your motor driver from getting overcurrent and over temperature. So if those protection is there, that's good. If not, you have to implement those protections manually. Like you have to put some thermal sensitive fuses or current fuses to protect your motors against high currents. Right. Now we have a complete mobile robot. We have discussed about the chassis, batteries, motors, wheels, and the connecting mechanisms. Also the electronic parts like microcontrollers, motor drivers, and ESCs. Now we have to see what are the available types of weapons. So here I'm going to show you 9 different types of weapons. You can select which one suits the most for your robot. First one is the wedge. As you can see, this is the basic uh, shape of basic battlebot shape, a very simple one. So this is very this can be, you can make your robot very rigidly if you're going to use this weapon or the mechanism. So this design can easily penetrate through the other robot's ground area and lift the robot. You can put a lifter in front of this robot. So this is the wedge type of a weapon. The spinner is like this metal shield, which is the top enclosure part of the robot, is spinning at high RPMs around the robot. So the opponent robot cannot reach or damage your robot. It will be a disaster if someone comes here, if the opponent robot gets a hit from this kind of a robot. And this kind of another robot type, as you can see, there is a high weight drum inside of the robot, so it can provide very destructive hits. So this is another type of a weapon. Also, this is the crusher. What it does is like it can get the opponent robot lifted here, and using this crusher, it can penetrate uh, to the other robot and damage the internal components like batteries, motor drivers, or the electronics. You can penetrate the robot and damage. Flippers are another type of weapon. As you can see here, this robot utilized with the pneumatic or a hydraulic flipper. So you can flip the opponent robot upside down and push the other robot to the pit as well. This is the horizontal spinner. So as you can see, there is a very rigid spinning element in front of the robot, which can spin at very high RPMs, like 1,000 or 10,000 RPMs. So it can also generate very high impacts upon a collision. Similar to the horizontal spinners, we have vertical spinners also. So vertical spinners also uh, provides very high impact upon a collision. This hammer type of a weapon is not very common in Sri Lankan context, but in the world robotics, world battlebot context, is a very popular option. In Sri Lankan context, it is not very much used because of the weight limits of the robot. So it can give a powerful blow to the robot, to the opponent robot. Also, it can be used to correct your robot if your robot also get flipped. And the last one is hybrid design. As you can see in this image, this robot consists of this wedge type of things, and the flipper also a vertical spin. So based on the opponent robot, you can use this. You can use any of these mechanisms to damage the other robot. So I have seen several weapon types to you. So it's up to you to design which type of weapon that you are going to use for the battlefield. Uh, these are the actuators or the mechanisms that you can use to control the control the weapon of your robot. You can use DC motors, stepper motors, or servo motors, or DC brushes motor, whatever the motor that you want to control the robot. Also, you can use hydraulic and pneumatic actuators. Uh, the thing is that you cannot use these kind of uh, actuators for the driving mechanism of the robot, but you can use these for the weapon system of your robot, because you don't have to store much energy for this, right? Uh, if you are using a flipper, you just have to use 10 times in a game, right? So you can store that kind of energy inside the robot and use flippers if you want. Right. The last and the most important part of the robot component selection is the switches, right? So as I said earlier, you are required to have two switches, I guess. The first one is to stop the drivetrain, stop the motors, and the other one is to stop the what we call the weapon of the robot, right? So when selecting a motor, there are two considerations. First one is the current. So if you, let's say, you're using 4 motors, and each motor can draw up to 10 amperes. So your switch can withstand more than 40 amperes at a given moment, right? That's a basic calculation. So you have to calculate all the current drawing equipments and see how much current will this draw at a given point, and get a switch which can withstand this current, this amount of current. Also the voltage. You have to verify that the switch is rated to the maximum voltage of the battle power system, which is 48 volts at max, right? And when placing the switch, you have to think about the proper location and proper mechanism to place your switches, right? You have to make sure these switches are not reachable by the other opponent. Let's say the other opponent damage this switch or turn this switch off. You don't have any chance to turn this switch on again, right? You will be disqualified or you will be defeated. So make sure these switches are not accessible for the opponent robot, but you can access these switches very easily and turn it on off upon a request. Right. So those are the things that I have to cover during my part of this session. I think my friend Sadharan is waiting to deliver his experiences and the knowledge with you guys. So I'm handing over this session to Sadharan to continue. And if you have any questions from what I have covered, please put them in the chat box. I will answer all of them uh, during this session. Sadharan,
Hello.
over to you.
Thank you, Chavira. So, yeah. Uh, can you see my screen?
Yes, I can see.
Okay. Right. Session 2. Chavira is giving a very good start for this session. So I will continue now. I'm Sandra Madhushankar, electronic engineer at Zone 24/7 Private Limited. I will start as a first thing to how we design our battlebot before making, how we discuss with our team, and what are the components that we are going to implement in our battlebot, the all features. Before that, we have to implement using any kind of simulation software. There are several simulation software. We can use SolidWorks is a one, AutoCAD, and several tools we can use.
So that let me interrupt. Your Google Meet is also visible at the part of the slide deck. It covers some of the content in the slide. Can you place the Google Meet window?
All right.
Mini window. If you can, but if you can share only.
All right.
Now it's better. Yeah.
Okay, thanks. So, right, design a battlebot that can be made. So before the made robot, we can get very advantages if we can design a battlebot using any CAD model, using a software. There are several advantages we can earn. The first one is we can get best reduce the cost, and we can get around estimation count, and we can think about different manufacturing available around ourselves, and get brief overall idea about the robot, and what are the motors, what are the actuators, what are the weapon tools we are going to integrate in the robot. And before made, we have to simulate, and we can model using any kind of SolidWorks and any modeling. As a first step you can follow, you can discuss with your team, and you have to finalize the features you are going to implement in the battlebot. What are the components, what are the actuators, what are the Chamira mentioned earlier, the best motors, actuators, drivers, power, batteries, all things you have to finalize with your team. Then after the finalizing all features and all functions, you have to draw it in yourself in the drawing sheet. And one person can draw the and model the particular model using any kind of 3D modeling software with your requirements and your team suggestions. Then you can get a lot of idea about how we move these motors, and what are the spaces availability in your robot, and what are the weight, what is the gravity point in your robot, and you can get the more details before make the robot. If not, then you are all me also in the university, we are get directly make the robot. So after that, we are facing different problems without designing. So that's a major thing you have to follow before the make robot. You have to model the robot, and if you can simulate, that's better, right? So the other important thing is how you prepare while the robot is competition. So because part of the entire robot can be damaged even if you win a round. So how you prepare it? So you have to bring it all tools, extra parts, batteries, chargers, motors, and Chamira mentioned earlier. You have to design the robot. You can very easily replace those module if your robot got damaged. You have to replace the battery. You have to replace the motor controllers. You have to turn off any power switches, and relatively you have to design the robot with a few times you have to change your components within robotics competition. And your driving strategically, that strategic is very most important thing. You have to pick some person from your team who can control the robot it's very smoothly. And while the competition, you have to communicate with your team members, and you have to get ideas what we are going next step and other things. And move to the very important part of my session. So what are the best practices and tricks we have to use in the BattleBot competition? I have seen a lot of competitions in Sri Lanka, and Chamir also, he judged a lot of competitions in Sri Lanka. He has very good experience, and I discussed with him last week about this. What are the best practices and tricks we have to follow up in the robotics competition, BattleBot competition? And as a first one is a mechanical enhancement. We can do the mechanical enhancement. Follow up these topics. If your team have confidence to compete with other teams, your confidence level is better, right? ඔයාගේ team එකට ඔයාට BattleBot competition එකේදී confidence level එකක් තියෙනවා නම් අනිත් team එකත් එක්ක defeat කරන්න හොඳ confidence level එකක් තියෙනවා නම් to winning stage, ඔයාට winning stage එකට යන්න ඕන කරන tricks and best practices එක තමයි අපි දැන් discuss කරන්න යන්නේ. This is a discuss. You can ask question in chat box. So what is the best practices we have to follow to go to the winning? Right. The first one is robot can move both directions. When feature ka mama godak dakka huwa vella satibba university ke ka robot ganike advantage එක. තහ ගොඩක් robot use කරනවා. The robot can move both directions. The opponent robot when flip your robot. So then other side, the bottom side also you can move the robot because both wheels are exposed for the top side, right? You got my point, right? Opponent robot ඔයාගේ robot flip කරොත් අනිත් පැත්තට එතනින්ම ඔයාගේ ඔක්කොම effect එක ඉවරයි ඔයාට මේ feature එක නැත්තම්. Opponent එකනේ top side එකෙත් ඔයාට robot flip වුණාට පස්සේ move කරන්න බැරි feature එක move කරන්න බැරි නම් ඔයා කොච්චර දාන කොච්චර effect එකක් දැම්මත් කොච්චර හොඳට මේක optimize කරත් කොච්චර හොඳ controller කෙනෙක් හිටියත් කොච්චර හොඳ weapon එකක් තිබ්බත් ඔයා fail එතනින්. මොකද ඔයාට ඒ පැත්තට move වෙන්න බෑ. එතකොට ඒ advantage එක ගන්න. The best way is to make your robot can move both sides, up and down. The first thing is. The second one is, if you can cover your robot using metal enclosure, this better, because most of the robot made to the attack your robot, right? So if you can develop a metal enclosure outside in your robot, you can save all mechanism, all actuators, all batteries, all things you can safely, and you can safely move. And other one is when you develop some weapon and defensive component, you have to implement some simple and one weapon too. අපි ගොඩක් දැකලා තියෙනවා competitions වල judge කරන්න යනකොට සහ competition බලන්න යනකොට ලංකාවේ domain එකේ ඉන්න ගොඩක් එක එක විවිධ වර්ගයේ tools high කරනවා. එක පැත්තකින් fire කරන්න හදනවා, එක පැත්තකින් හැම එකක් high කරනවා. ඒ වගේ ඒගොල්ලෝ හිතනවා ඒකෙන් ගොඩක් tools ඉපහම damage කරන්න පුළුවන් කියලා. හැබැයි ඒකට යන effect එකත් එක්ක ගත්තහම ඔයා කරන්න ඕනේ one simple unit of one simple weapon and very easily to handle this. එතන මම select කරපු එකක් තමයි මේ lift කරන එක. ඔයගොල්ලෝ competitions වල දැකලා ඇති. lift කරන එකේ ලොකු advantage එකක් තියෙනවා. මොකද අනිත් පැත්ත opponent robot කොච්චර strongly කොච්චර control එකකින් යා drive කරන. If you can flip this opponent robot, they can't do anything. කොච්චර powerful robot කෙනෙක් වුණත් ඔයාට යාව lift කරලා ගන්න පුළුවන් නම් එයා කොච්චර heavy විදිහට කොච්චර අපට attack කරන්න කොච්චර අමාරුවත් එයා flip කරන්න පුළුවන් නම් අපිට win කරන්න ලේසි. In the robotics competitions, there are two paths. The one path is you can destroy opponent robot. The other part is without doing more effective. ඒ කියන්නේ ඔයා කොච්චර effect එකක් දාලා එහා පැත්තේ රොබෝව destroy කරන්න try කරනවාද කියන එක පාත් එක. ඒ පාත් එකෙන් කෝකද තෝරගන්නේ කියන එක තමයි your choice එක. You can the other path to win as simply without getting any එච්චර ලොකු effect එකක් දාන්න නැතුව getting any effect you can win. The other path is you can destroy the opponent. එතකොට ඒ path එක different path. There are two different paths. එතනදී ඔයා focus කරනවා winning path පැත්තට යන්න. එතකොට ඔයා කරන්න ඕනේ මේ වගේ simply mechanism එකක් එක්ක කොච්චර safely robot control කරනවද කියන path එක යන එක තමයි safe. ඔයා try කරනවා හැබැයි robot destroy කරන්න. එතකොට මේ වගේ tool එකකට වඩා හැම එකක් වගේ ඒ දේවල් use කරන්න පුළුවන්. හැබැයි මම recommend කරනවා අපි හැබැයි robot destroy කරන්න ලොකු effect එකක් දානට වඩා simply the less effect එකකින් winning path එකට යන එක තමයි better way. මොකද අපි මේක robotics competition එකට යන්නේ win කරන්නනේ. එතකොට ඒක පොඩ්ඩක් make sense ඔළුවේ තියාගන්න. The other trick is I learned something from the micro mouse, this mechanism. අපිට පුළුවන් නම් මොකක් හරි mechanism එකකින් යට surface එක drag කරගෙන ඉන්න. To strongly grabbing the bottom surface. ඒ කියන්නේ අපි හිතමු අපි high කරලා තිනවා යටට solenoid magnet panel එකක්. එතකොට යට magnet surface එකක් metal surface එකක් නම් තියෙන. අපිට trigger කරන්න පුළුවන් මෙන්න මේ solenoid valve එක. When triggering the solenoid valve mechanism, we can strongly grab the bottom layer. So other opponent robot can't move our robot. It's very hard because we are grabbing strongly the bottom surface. But unfortunately, our and all robotics competition not using a metal surface for the bottom, and they are using wood or aluminium. The aluminium is important. The magnet can't respond with the aluminium, right? So unfortunately, we can't this mechanism. So other one is what is this? What is this? This is a suction, vacuum suction mechanism. The suction mechanism using for the micro mouse. Some very efficient micro mouse, they are moving very speedily and should sometimes the micro mouse are flipping. So avoid this, the flipping. They are using the strong suction mechanism, the mini suction mechanism inside of the micro mouse. If you can using the suction mechanism to your robot, අපිට මේ magnet වලින් ගන්න force එකටම ගන්න බෑ. හැබැයි යම් තාක් දුරකට වට force එකක් ගන්න පුළුවන්. මෙන්න මේ ductor fan එකක් වගේ ටිකක් most powerful fan එකක් use කරලා මේ වගේ suction mechanism එකක් ඔයාට ඔයාගේ robot එක යටින් high කරගන්න පුළුවන්. You can get a very strong grabbing mechanism. ඒකේ advantage එක මොකද්ද? ඔයගොල්ලෝ දන්නවා physics වල surface එකත් එක්ක තියෙන force එකට අපිට තියෙන සමීකරණයක්. ඒකේ මේ wheels වල surface area එක කොච්චර දුරට touch වෙනවද කියන එක මත රඳාපවයි. එතකොට අපිට පුළුවන් මේ robot ගේ gravity point එක හරහා පහළට දෙන force එක වැඩි කරලා මේ robot ගේ අපි කියන ඒකට ඝර්ෂණ බලය කියලා. ඝර්ෂණ බලය වැඩි කරන්න පුළුවන්. එහෙම කරොත් අනිත් robot වගේ robot මොකක් හරි existing තැනකට තල්ලු කරගෙන යන්න තියෙන possibility එක අඩුයි මේ වගේ අපිට force එකක් ගන්න පුළුවන් නම් යට bottom surface එකක් එක්ක. It's a very good advantage and it's a trick we can call as a trick. So the other one is I have seen some videos and I saw this video and I attached the link also. There are two controls. If you can see a very in detail in this image, there is a very good robot and there is a two controllers. the one controller control the robot directly, and other person control the weapon. The both are control very both are control the robot simultaneously. So that's very good thing, because the one person control the robot, they can't get the decision with controlling the robot with the other weapon. So this is a point to avoid this, and we can get more efficient movements, and we can attack the opponent robot if we can use in the two controllers in the robot, right? And other trick is this one is controlling enhancement, right? This trick I learned from the program. I present as a programmable enhancement, and Chamira mentioned earlier. If you use the third-party controller to control your robot, it's a disadvantage, right? If you can control the DC motor directly using your RC receiver, it's better. I also recommend this one. Can order පුළුවන් නම් ඔයාගේ DC motors control කරන්න third party programmable එකක් නැතුව කෙලින්ම එන RC receiver PPM module එකෙන් ඔයාට පුළුවන් නම් ඔයාගේ motors control කරන්න. This is a good way. You can control, or you have control in your robot. ඔයාගේ control කරන robot control කරන කෙනාට ඒ control එක ගොඩක් තියෙනවා. මොකද robot battle එකක අනිත් opponent robot ඔයාට attack කරනකොට ඔයාට ඉක්මනින් decisions ගන්න ඕනේ. ඒතර ඔයාගේ decisions pre-process එකක් through නම් යන්නේ. ඒතර පොඩි delay එකක් එනවා. ඒතකොට ඔයා ගන්න decision එක නෙවෙයි directly apply වෙන්නේ robot pre-process එකක් through යන්නේ. ඒතකොට ඒක avoid කරන්න ඔයාට directly Chamira mention කරා කලින් ඔයාට පුළුවන් නම් robot use කරන්න third party programmable එකක් නැතුව, it's better way. But this feature I suggest to if using very emergency purpose, right? So this is A is your robot, B is a opponent robot. In T1 time period, the situation is the B robot pushing your robot to the existing box, right? You have to avoid this situation, but you have no time to get decisions. When your robot driver try to turn the robots, but it's not working because the opponent robot very speedily you force into the existing box and destroy mechanism here. Right? What we are going to do is, and my suggestion, if you've seen the sumo robot, this feature they used, right? The sumo robots, this feature used. But now you can implement third-party microcontroller and your own program to emergency switch to your own program using any kind of trigger button. The function is when the opponent robot pushing your robot to the existing box, your robot, then we activate the trigger button, offensive trigger button. Then robot disconnect with your PPM module, or you can decide it. The automatically robot turn the right side and go. Then in T1 time period, robot with your robot in here, then automatically go in this area, and then turn to the opponent robot, and automatically, or then you can get the manual mode and push it to the existing box. This is the mechanism I suggest. මෙතනදී ඔයගොල්ලෝ කරන්න ඕනේ මොකක් හරි urgent වෙලාවක. ඒ කියන්නේ opponent player ඔයාගේ මෙන්න මේ stage එකට යන්න ඕනේ. ඔයාට manually ඔයාගේ robot confidence නම් control කරන්න. ඊට පස්සේ the feature is enhancement. ඔයාට within එකට යන්න නම් මෙන්න මේ feature එක try කරලා බලන්න පුළුවන්. මෙතනදී වෙන්නේ opponent robot ගොඩක් ස්පීඩ් එකෙන් ඔයාව තල්ලු කරගෙන යනවා. මෙතන මොකක් හරි destroy mechanism එකක් තියෙන තැනකට හෝ exit වෙන තැනකට box එකකට. ඒ වෙලාවට ඔයානම් control ඔයාට decision එකක් ගන්න බැරි නම් මොකද්ද බං කරන්න කියන එක. quickly ගන්න ඕන decision එකක් මේක. quickly control කරන්න ඕනේ. එච්චර quickly ඔයාට මේ robot control කරන්න පුළුවන් නම් okay. එතනදී කරන්නේ එහෙම කරන්න බැරි නම් අපි ගාව තියෙන trigger function එකක් as a backup plan. then we trigger out this function. We trigger කරපු ගමන් වෙන්නේ අර manual mode එකේ හිටපු manual mode එක කියන එකේ අදහස තමයි ඔයා directly ppm receive එක through motor වලට access වෙලා ඔයා motors control කරන ගමන් ඉන්නේ. ඒ වෙලාවේදී එන emergency purpose ඔයා trigger button එකකින් ඒ mode එකෙන් අයින් වෙනවා. අයින් වෙලා automated mode එකට යනවා. එතනදී ඔයා මේ code එක program කරලා තියෙන්නේ. දැන් robot වැඩ කරන්නේ programming auto mode එක. manual mode එක නෙවෙයි. එතනදී වෙන්නේ robot එකපාරට ස්පීඩ් එක පොඩ්ඩක් පස්සට ඇවිල්ලා ඔයා රොබෝ පස්සට ඇවිල්ලා ටර්න් වෙනවා අංශ කරනවා දකුණු පැත්තට හරි වම් පැත්තට හරි වට ඒක ඩිසයිඩ් කරන්න පුළුවන් ඉන්න තැනත් එක්ක ඊට පස්සේ ක්වික්ලි ආයි මෙයා මේ පැත්තට ටර්න් වෙලා මේ පැත්තට යනවා T3 කියන පීරියඩ් එකේදී ඊට පස්සේ දැන් මේ රොබෝ ඉන්නේ දැන් ඒ රොබෝ මෙතෙන්ට ඇවිල්ලා ඉන්නේ මෙතන දැන් B රොබෝ මේ ඔයාව තල්ලු කරගෙන ස්පීඩ් එකෙන්ම මෙයා අයින් වුණ ගමන් මෙයා පොඩ්ඩක් තව ටිකක් ඉස්සරහට එනවා. ඒක වාසි. මෙයා දැන් කොටුවල ටිකක් ලඟ වෙලා ඉන්නේ. මේක ගොඩක් ස්පීඩ් කරන්න ඕනට. ඊට පස්සේ ඒ රොබොට් මෙතන ඉන්නවා. ඔයාට ලේසි මේ රොබෝ මේ පැත්තට හැරිලා ඉන්න නිසා මෙයාට පොඩි ස්පීඩ් එකක් තියෙනවා. ඒ ස්පීඩ් එකත් එක්කම ඔයාට මෙයාව එළියට තල්ලු කරලා දාන්න පුළුවන්. මෙන්න මේ ෆීචර් එක ඔටෝමේට් මෝඩ් එක. එතකොට මෙතනින් එහාට ඔයා මැනුවල් මෝඩ් එකට ගන්නවද නැත්නම් මේකත් ඔටෝ මෝඩ් එකේම යනවද කියන එක ඩිසයිඩ් කරන්න පුළුවන්. ඔයා හිතලා බලන්න මෙන්න මේ ෆීචර් එක. යන මේක ගොඩක් අර ජපනීස් sumo robotics companies වල use කරන trick එක. If you want to apply some new things and you have to introduce some new features to the Sri Lankan robotics battlebot domain, that's better and I recommend it to do that. And if you are going to participate the first time, please focus to the other robot to learn something from these robots. At least one feature and one technique you have to learn from other robots. And try to next time enhance this feature and optimize your robot. I will share some video about the Sri Lankan robotics competition. I think it's not audible, but this both robots have a lifting mechanism and you can learn what is the advantage when you integrate the lifting mechanism to your robot. You can see there are two components in both sides, right? This is a duct fan. I mentioned earlier. This is a duct fan they use to the getting the force to the straight right. මේ duct fans මේක අපේ team එකේ හිටපු එක member කෙනෙක් අපිත් එක්ක කලින් හිටපු member කෙනෙක් participate කරපු competition එකේ ගලක රොබෝ කෙනෙක්. මෙතනදී ඒගොල්ලෝ ඉස්සරහට force එක ගන්න force එක වැඩි කරගන්න duct fan දෙයක් ඉස්සරහට හයි කරලා දෙනවා. duct fan එක ලොකු force එක generate කරනවා. air force එක. ඒ mechanism එකට යන්න පුළුවන් නැත්නම් ඔයාලට පුළුවන් අර විදිහට duct fan එකක් වගේ bottom surface එකට apply කරලා ඒ පැත්තෙන් ලොකු grabbing force එකක් ගන්න පුළුවන්. එහෙම නැත්නම් මේ විදිහට straight force එකක් additional force එකක් apply කරන්න පුළුවන්. Yeah, that's it from my side. If you have any question, you can ask from me and Chamira here.
Excuse me.
Hello. Yeah,
Uh,
you can ask if you have any questions.
uh, so I checked all in Colombo to buy a brushless DC motor that has a high torque, but I all the things I found in Sri Lanka is just the motors used for drones. Can you mention any place to buy high torque brushless motors?
As I mentioned in the comment section, the chat box, put on like we also believe that the components available in Sri Lanka is not sufficient for a battle mode. So what we would suggest is to purchase as much as components from the overseas vendors, right? You can use Banggood, Bijiki, Volvo, and some other vendors from in China, some other components, some other vendors. So that what we would suggest, like I know like there is not enough time for you to purchase now. So there are two options for you. First one is to build your battle bot with the components that you have in hand, or else you can borrow some components from your seniors, like your university seniors or school seniors. They might have some components. That are the options that you have. But going forward, like if you are really into battlebot, but what I would suggest is to don't wait until a competition comes, right? Before a competition, it's not like in next year. Usually, we will have three or more battlebot competitions. So you can get prepared now and order components now and start building your battlebot now. So you will not run into component shortages at the last.
Thank you, Mr. Chahiro.
Mr. Chamira, I think we have another question from chatbot. Sorry, chat.
What are the other questions we have?
Uh,
I think I have answered all.
nice. Saven Fernando is asking, can you guys consider the increase in the weight of that question?
Uh, I think that is out of our scope. We will have another awareness session to discuss all the guides and rules specific to this competition. The competition organizers, can you please answer this question whether you can increase the weight or not? I think we have clearly mentioned the weight is 15 kilogram, and that was the weight allowed in the NIBM, sorry, Japur robotics competition as well. So if there is any room, I think that question is for you guys, for the organizers.
Yes, I think we won't be able to increase the weight for this competition because, as you all know, like increasing the weight is not just like amending a rule. So if we increase the weight, we need to increase the strength of the arena as well. So at this point, it's not possible to do that, but we will try to consider to increase it in the next competitions. So you might know, like in the previous competitions, the weight was like 10 kg. So slowly we are trying to increase this. So we'll see in the next competitions how we can increase this weight. But for this NIBM competition, it would be the max weight would be 15 kg.
Do the participants have any other questions to ask?
Yeah, if we borrow two lithium polymer batteries, will that be enough? Like when we are playing one battle, we can charge one, and how many rounds we will be playing on one day.
Uh, the number of rounds that you will be playing in the day will depend on the number of participants coming on a particular day. Two batteries will be enough, and make sure to bring a charger. We will provide AC power outlet so you can charge the spare batteries while you are using the other battery in the robot. Two batteries will be enough.
And it's hard to find brushless motors in Sri Lanka. Will it be fine if we use brush motors for our weapons?
Yes, definitely. As I mentioned earlier, like there are two types of motors, brushed and brushless DC motors. Those two types of motors are compatible for a battle boat. Make sure to use a gearbox attached to a brushed DC motor if you're going with a brushed DC motor. You can purchase motors with a gearbox if you're going with a brushed DC motors in PETA or some online vendors as well.
Yeah, and one more correction. I didn't find any brushed ESCs in Sri Lanka, so we have to use a motor drive and use Arduino to code it, right?
Yes, if you don't have an have a brushed ESC, you have to use a intermediate microcontroller. Uh, I don't know a specific place to buy a brushed ESC. So you can try PETA or some online vendors. Otherwise, you can purchase them overseas.
And will it be okay to use only two drive motors to our battle boat, or we should have a four-wheel one?
That's up to you. Like based on the design of your robot, based on the weight that you are going to have in the robot and the driving strategies and the design of the robot, the powertrain, you can decide how many motors that you are going to use. Some of you can use two motors, others can use four or six motors based on the design that you're going to use. There is
Uh,
no hard and fast rule to use four robots, four wheels or four six wheels.
if we use four driving motors and I should get four more drivers, will one Arduino board enough to program all of this?
Uh, that's also depends on your requirement whether you're uh, running two motors in parallel or not. I think like a single motor requires only three controlling signals. So if you're using four motors, that means 12 controlling signals, which Arduino Uno can provide. Otherwise, you can go for a higher microcontroller.
Yeah, thank you.
Right. So I saw some questions related to some of the stuff that need to be discussed, which are rule based. So don't worry, we will be having a session that will cover all the rules and regulations for the IROBEX Battlebot competition. And are there any more questions before we wrap up the session? Right. So Savane, I hope I pronounced that right. So that information we will be providing that to you in that next session, which we will be organizing. The session which will cover the rules and regulations document. And so, any further questions, you can contact the organizing committee and we can clarify that with you. Uh, so, before we wrap up the session, I would suggest that everyone switch on their cameras because we want to take a group picture of every single participant. So can everyone switch on their cameras?
And Mr. Jamir and Sadhuran, can you please switch on your camera?
Zero, I'm sorry, I'm unable to turn on the camera. I'm outage.
Ah,
Yeah,
it's
that's
okay.
sure. That's sure.
Yeah.
No problem.
Okay, guys, say cheese. Let's get another one. Right. You can end the session.
Right. So that's, and now we wrap up our awareness session on how to make a battle robot for the IROBEX battle robot competition. A huge thank you to our speakers, Mr. Chamir Vijayatunga and Mr. Sandruan Madhushankar, for sharing their expertise and valuable insights with us today. It has been incredibly informative, and I'm sure all of our participants have gained a lot of knowledge and inspiration. Thank you to all the participants for joining us today and for your engaging questions. We hope you enjoyed the session as much as we did in bringing it to you. Wishing you all the best in your BattleBot building journey. Have a great evening, and we look forward to seeing you at the IROBEX competition. Thank you all.
Thank you very much, the IROBEX organizing committee, for inviting to this session. We also would like to wish all the best for all the competitors who are going to participate in the IROBEX 2024 in upcoming weeks. Thank you very much.
Okay, guys. Thank you. Good
Thank
night,
you.
all.